What up, athletes? Whoop, whoop. All right, let's do this. We got a lot of ground to cover. What happened to the... Oh, there we go. Boom, put you right there. All right, today's learning target is I will find midpoints and bisect line segments. I will find midpoints and bisect line segments. Awesome. Go ahead, do your warm-up. And I'm going to assume you pop. By the way, anytime I tell you do something, do it, pause me, and then go ahead and do it. I'm hoping you're pausing it so that you're getting the most out of this educational experience. Let's roll with this. This is going to turn into subtraction, right? And when I subtract these, that's simply 0.9. This is addition, and when I add those together, I'm going to get what? Negative 37.43. Those become subtraction, and I end up with negative 1/6. And last, when I figure these out, you get common denominators, I end up with negative 3/8. Boom. Okay. So let's roll with this. We are going to go look at the vocabulary for today. And you guys have a few here: segment, bisector, bisect, equidistant, and midpoint. Go ahead. I'm going to assume you're going to pause this, write it down, because I'm not holding it up on the screen for long. All right. We're going to call that the thing. So let's move on down to here. A midpoint on a number line. Actually, I do want to go back there. I have a slide for this. We don't have a lot of slides today, but we do have a couple. Okay. So, midpoint on a number line. Right here. Boom. If AB, we see AB right here, and that's also on your paper, you'll notice a box with this drawing in it, has endpoints at x1 and x2 on a number line, then the midpoint M of AB has the coordinates M equals x1 plus x2 over 2. In other words, add your two number line values and divide by 2. We're going to do several examples of that here in just a moment. But again, pause this, make sure you write this down, and then we're going to move on. Ready, set, go. Okay, I'm assuming you wrote that down, and let's do some examples with that right here. Okay, so find the midpoint for the following segments. Okay, so we're going to look at A is negative 4, and C is 3. So to find our midpoint, we're going to say negative 4 plus 3 over 2. Which is negative 1/2. Boom. That's your midpoint. So M equals negative 1/2. Probably should label it M for midpoint. How about for BE? We got B equals negative 1. E equals 8. So our midpoint is going to equal negative 1 plus 8 over 2, which equals 7/2. Or 3.5, either one. For CE, why don't you take a minute, pause me, try to do CE and AD on your own. All right, after that pause break, let's do this. I know that C equals 3, E equals 8, 3 minus 8 over 2. I meant plus 8, not minus 8. What am I thinking? Sometimes, right? Which is 11/2, or we know that our midpoint equals 5.5. Either one. And then A equals negative 4, and D equals 6. So I'm going to have negative 4 plus 6 over 2. The midpoint equals that, which equals 2 over 2, or 1. Awesome. So that is finding the midpoint. So we're going to do the same thing right here. The temperature at 11 a.m. and 8 p.m. are shown. Find the midpoint of these temperatures. Well, I have 20 degrees Fahrenheit and 6 degrees Fahrenheit. So to find the midpoint, I'm going to say, all right, the midpoint is equal to 20 plus negative 6 all over 2, which that becomes a minus, which equals 14 over 2, or that equals 7 degrees. So the midpoint of the temperatures is 7 degrees. Awesome. All right, we're going to take a look at the midpoint formula on a coordinate plane. This is where it gets interesting. So it's really the same thing with what we just did on the x-plane, because if you think a number line is really just an x-axis, right? Now we're going to do the same thing on the y-axis. So what is the midpoint formula? Well, you see it right here. Let me actually zoom in just a tad. Control plus again. That's a little bit easier to see. If PQ has endpoints P, which is just an x1 and y1 coordinate, and Q, which is an x2, y2 coordinate on the coordinate plane, then the midpoint M of PQ has the coordinates M, which is x1 plus x2 over 2, which is just our number line, right, on the x-axis, and y1 plus y2 over 2. It's just averaging both values. So pause this, write this down, because we're going to head back to our regularly scheduled program right now. Go ahead and zoom back out here. Maybe. Maybe this is not control. Oh, we're having a momentary issue of Zoom, but that's okay. Life works anyway. So I'm assuming you wrote that all down. And it says right here we have an example. It says find the midpoint of AB for A equals negative 2, 1, and B equals 8, 3. I don't even need a drawing to do this because I'm just going to average my x values. So my midpoint is going to equal, let's start with my x. My x is going to equal negative 2 plus 8, right? I'm doing the negative 2 and the 8 all over 2, which is 6 over 2 or 3. Boom. And then my y is going to equal 1 plus 3 over 2, which equals 4 over 2 or 2. So what does my midpoint equal? We'll write it down here in the margin, equals the 0.32. Boom. And that would be right in between on that graph. There we go. Okay, I'm going to go to the back side, try some examples out. Let's try one more together. Okay. And that one more together says, all right, we have 1, 8 and 7, 4. So to find my x values, I'm going to get 1 plus 7 over 2, which equals 8 over 2. And that is 4. To get my y value, I'm going to add them. 8 plus 4 over 2 equals 12 over 2 or 6. So now I know that my midpoint is at 4, 6. There we go. Take a minute, pause this. Try the next one. Okay. So I'm going to add them together. For my x value, it is negative 6 plus 5 over 2, which equals negative 1/2. And then for my y, it's 2 plus 7 over 2, which equals 9/2. I'd also write this as either negative 0.5 and 4.5. That's probably how I'm going to put it in. So for my midpoint, it's going to be negative 0.5, 4.5. Boom. Or you could have done negative 1/2, 9/2. Either way is fine. Okay, I didn't realize that was hidden. All right, so find the midpoint's not bad at all. What about it if we're missing a coordinate on